All right, guys, so we're going to talk about fractional exponents again. And the first part of our lesson is to decide whether these two things are the same. Are they the same? Well, whenever you have something raised to a power, you use something called the power rule. Could somebody say that in like layman's terms? Teddy. Yep, you distribute this power inside, so here you get x. And what's 13 times 1/7? 13 over 7. And so let's do it again, right? Now you'll see that they're just reversed, and we're going to distribute in what's 1/7 times 13. So they turn out to be the same thing. That's really interesting, right? Really interesting. Well, it produces a rule. This. On Friday, I showed you the bottom. But your Regents gives questions and will give you multiple choice answers where you have to notice the two forms. And so that's our study of today. A little bit. Does everybody, the I stands for the index. So the bottom number, no matter what, is always the index. And the top number is always the exponent. It just turns out, because of the commutative property, it doesn't really matter the order of where you place them. It just matters that you know which one is which. And so, remember. So here's what we're going to do. Evaluate. Of course, we can plug this simply into our calculators as 16 raised to the 3/4 power. But I want you to get used to how it could be written so that you could recognize it in the multiple choice of your Regents. Take a minute, write it down, have a guess at it, the two separate ways, and then we'll figure out how much it actually is in the end. We're wrapped up. Okay, here we go. Dan, tell me what you're going to do. Yep, that's certainly one way it could have been written, right? The index and then the exponent. What's the other way it could have been written? Yeah, very nice. Very, very nice. That's the two ways it could be done. Let's find out how much each one is. Let's plug that into your calculator, figure it out. Comes out to be 8. I agree with that. The 4th root of 16, something multiplied by itself 4 times, that could be 16 is 2. And 2 cubed is 8. And then 16 cubed, I think, is 4,096. What? And then the 4th root of 4,096 is 8. Something like that. Right? That's good. Yeah. Piece of cake. Let's play again just to make sure that we get the hang of this. Please take 4 raised to the 3/2 power, write it 2 separate ways, and then find the answer. Teddy, what are the 2 ways that you could write this? Okay. Oh, I like that. Very nice. That's one way. What's the other way?
And 2 in the index.
Mm-hmm.
4
4 cubed?
Yeah.
Yeah, that's great. And so what's the answer in both instances? Yeah, the square root of 4 is 2 and 2 cubed is 8. The 4 cubed is 16 and the square root of 16, I'm sorry, 4 cubed is 64 and the square root of 64 is 8. And everybody knows that if you wanted to punch this into your calculator using the exponents, you'd have to use parentheses. Do you know what I mean, or do you need to see that? Okay, good. All right, let's keep going. So now we're going to try this. Now we're going to review a little bit of exponents and make sure we know what's up. So something raised to the negative power. Let's deal with that first. Raised to the negative power. Do you flip everything or just the stuff in the parentheses? Nope. Just the stuff in the parentheses. Just the stuff in the parentheses. Remember that. So in order to make this a positive exponent, this then becomes n raised to the 2/3. You see? Just the stuff in the parentheses, and then the exponent becomes positive. n raised to the 2/3. Well, let's try and re-express that using some kind of radical and exponent. The top is the exponent and the bottom number is the index. So this could either be written like the cubed root of n squared, or you could have said it's the cubed root of n squared. Either way, it doesn't make a difference. It's the same thing. Problem number 5, you know. So now we have some things, we got them raised to some exponential powers, and the goal is to combine them underneath a single radical if you can. Do you think we can? What do you think? Yeah. I don't know necessarily about multiplying them first, because you do not have the same bases, so you can't just add their exponential powers. Nope. Nope, nope, nope. Oh, you can't do that. You can't just multiply 6 times x and then a third times 2 over 3. But what you can do is the following. 6 to the 1/3 power is the same thing as the cubed root of 6. True? True story? Okay. And now, there are 2 different ways that you could write x to the 2/3. If you write it one particular way, it allows you to combine it with the 6 because they'll both be underneath the same kind of radical. Yep. Very nice, Teddy. That was a brilliant plan. Because now, underneath the same radical, any 2 things that are underneath the same radical can be combined, and so the final answer would just be the cubed root of 6x squared. And that makes perfect sense because look at what it is. Look at the exponential powers. It's great. It's awesome. Any questions? Good. I'm glad it's easy. Last problem of the day before we work on our Regents questions. Ay, ay, ay. Regents loves this. Loves this. I can't even tell you. They give fractions all the time raised to a power. Any ideas for what we could do? Angela, what are you thinking, girl? Not sure? Anytime you raise it to a power, you're always using the power rule. What's the power rule say that you can do? You can distribute. Very nice, Big Larry. Distribute this in anytime you see this. It's got to be distributed to everything. And so what's x to the 6 times a third? Very nice. And what's y to the third times 1/3? Yeah, that's it. There's nothing more you have to do. It's about knowing this property and doing the problems real quick. Done. That's it. That's all you do. End of story. We're good? Angela, you still confused? Every time you see something like this, always do that. Okay. On to your Regents questions. Your Regents questions for tonight will be collected tomorrow and graded.